Hello. At the outset, I welcome you to this short video on Introduction to DSpace. In this video, you are going to learn about what an institutional repository is, free and open source softwares for creating and managing the institutional repository, the features of DSpace, design policies, architecture of DSpace, logical structure of DSpace, authentication and authorization procedure in DSpace. Well, the lot of data is continuously being generated due to the teaching learning process, research activities, and the communication with the various apex bodies such as NAC, AICTE, Shivaji University, etc. Such large data needs to be captured, preserved, and archived for knowledge sharing and in timely decision making by extracting the information. That is where the institutional repository comes into picture. An institutional repository is a digital archive system developed by an educational institution. The technical definition of institutional repository is the institutional repository is a digital collection resulting from capturing, preserving, and disseminating the intellectual output of a single university community. Institutional repository is a digital open access system established by the institution which hosts the digital content. There are many free and open source softwares for creating and managing the institutional repository. DSpace, developed by MIT Libraries in collaboration with HP Lab, ePrints, Fedora, Greenstone, to name a few. DSpace can be installed both on the Windows as well as the Ubuntu operating system, whereas the ePrints requires the Ubuntu operating system. And in this video, my main emphasis would be in giving exposure to the logical structure of DSpace. So what is DSpace? DSpace is an open source software platform for creating and managing open access institutional repository for scholarly and or published digital content. DSpace hosts and provides online access to a variety of materials produced on the continuous basis as a part of teaching, learning, and research. Now I'm pretty sure you have a clear distinction between what an institutional repository is and what the DSpace is. Institutional repository is nothing but the digital archive system. It is a repository of the huge data which has been generated over a period of time, and the DSpace is a software platform for managing and creating such institutional repository. The features of DSpace. It helps in preserving the historical digital archives over a long period. So the huge amount of data you have got at the central location from where you can extract the data whenever on the need basis. Provides a browser-based solution for uploading, searching, and retrieving digital content of an institute. So DSpace provides different views to an end user. The JSP views, XML views, based on the role of that user, he can use different views. So the DSpace 7 has introduced few more views corresponding to Ember.js, AngularJS, which makes the DSpace accessible on the mobile devices. So it defines its own workflow module for data submission where each step of a workflow can be authorized. So this is similar to a research paper submission to a journal where it undergoes an editorial process where it can be accepted with a minor correction, major correction, or can be rejected. The same type of workflow module is in place in DSpace. Enables capturing item in any format. So it may be in the PDF format, textual format, audio, video, audio of different formats, different image formats such as JPG, GIF, PNG, RSS feeds, etc. Enables the user to subscribe to a collection. So the user is allowed to subscribe to a collection, and whenever an item is added to the collection, the user will be intimated through email. Policy-based storage and retrieval. Since the DSpace hosts also the sensitive data, the proper policy mechanism should be in place for storage and retrieval of data in DSpace. So there are few DSpace design policies which are to be followed for the better utilization of data from DSpace. Since DSpace hosts the huge amount of data, you cannot afford duplication of the content. So the first design policy is the duplication of content should be strictly prohibited. Role-based management should be in place to restrict right access to the content to the right person. Proper definition of access policies is mandatory. Storage and retrieval should be policy driven. DSpace has its own authentication and authorization mechanism for this purpose, which we'll be seeing in the coming slides. Now, this picture depicts a DSpace application architecture. DSpace follows a three-tier application architecture. The first layer, which is also known as the service layer or the presentation tier, consists of the implementation of the modules with which the user interacts. So it consists of JSP UI, it consists of Ember JS UI, Angular JS UI, Spring, Spring Boot, Spring MVC. Many different UIs are available in this particular presentation layer. The second tier is a business logic tier. For every feature that is supported by DSpace, there is a module in this layer, such as the workflow, authorization, authentication, browse, etc. And each of these supports an API which can be exploited by the programmer for interfacing his application with DSpace. The bottommost layer is a storage layer, which is divided into two parts, an RDBMS and a bit storage. RDBMS consists of the metadata information, and very important point here is the data is not stored in RDBMS, it is stored in a bit storage in the form of the bit streams, bundles, which we'll be studying during the different components of DSpace. Now we will explore the different layers of the DSpace application architecture in detail. From top to bottom, there are three layers: the service layer, business logic layer, data and storage layer. Service layer. This is the topmost layer of DSpace platform, which contains the implementation of the modules with which the user interacts. It comprises of various modules such as the Web User Interface module, Open Archive Initiative, Metadata Harvesting Protocol Service, etc. The business logic layer consists of modules for performing business logic of the system. Each module targets a specific functionality hosted by DSpace, such as browsing, authentication, authorization, workflow, content searching, etc. Each module hosts numerous public APIs, which are referred to as in-process application interface. It is on the top of this API, the services such as the web user interface, federation service, etc. are built, and each layer provides the services to the layer above it. The bottommost layer is the data or the storage layer, which consists of two components. The first is RDBMS system, and the second component is a bitstream storage module for storing the content. Each of these modules supports an API accessible to the business layer. We'll have a quick view at the logical model of DSpace. The different components of the logical model are the community, collection, item, bundle, bitstream, DC record, bitstream format, etc. For interpreting this figure, the M should be read as the multiple or the many. That means each community can have many communities or many collections. Similarly, a collection can have many collections or many items. An item can have many items or many bundles and so on. Whereas each item can have a unique DC record and each bitstream can have one and only one bitstream format. So DC stands for Dublin Core, which is the metadata standard of DSpace. Now we will explore each of the components of the logical model in detail. Community. Community represents the DSpace content at its highest level. We have the top level community. For example, the institution itself can represent a community. A community may be further divided into the sub-communities or the collections. For example, the sub-communities may conform to the different sections of the institution. such as the Knowledge Resource Center, the examination section, different departments. Each department may be having the different structural units and so on. A community can contain sub-communities or collections, and this particular structure you can compare with the operating system's file system, where a root folder consists of subfolders or the files. Each subfolder can contain further subfolders or the files, etc. A collection. A community may further be divided into the sub-communities or collections. Logically related material is organized into a collection. So what you will be uploading will go into the collection. For example, annual reports may represent a single collection. MSW project reports may represent another collection. Similarly, MCA internship projects, MBA summer internship project reports may represent the collections on their own. Item. At the lowest level of archival unit, we have what is known as an item, which consists of three discrete components: a metadata, bit stream, and a license. These are the few scenarios of the DSpace logical model. In this model, there is a single community which consists of a single connection with the item. Item consisting of metadata, content, and license. In this, the top level community consists of two collections. Each collection is having a single item. Here, the community consists of two communities. First community has a single collection, while the second community is having the two collections. To conclude about the DSpace logical structure, from the end user's perspective, a DSpace is nothing but an archival system which consists of collection of communities. Each community may be further divided into sub-communities. Sub-communities contain the collections pertaining to the different data of interest, and the collection consists of items, bundle, and finally at the lowest level of archival system we have what are known as the bit streams. Dublin Core Metadata Standard. At the lowest level, an archival unit is represented by an item which comprises of the actual content and the metadata. So each item is having two parts, the actual content and the metadata describing that content. This is very analogous to the table structure where there is a schema and the actual data. So metadata is nothing but the schema of the content of an item in DSpace. DC is a default metadata format for DSpace, which is customizable, but for that the admin rights are required. Few fields can be added, the existing fields can be edited. So DC metadata aims at interoperability and ease of discovery. As the content is submitted by the end user, the DC record automatically gets constructed. Here is a sample DC metadata structure which consists of different fields such as the title, subject, description, language, source, and so on. So the fields which are not required can be deleted by an administrator and the new fields can be added because every item may have its own set of the fields which are mandatory. Bit stream. So bit stream is a combination of items content and the serialized metadata. So there is another terminology which has frequently been used in DSpace, which is known as a bundle. So it is not necessary that an item should consist of a single bit stream. An item may comprise of more than one bit stream also. For example, if you are uploading an HTML file into the DSpace, the HTML file may make use of the CSS file for designing purpose and the JavaScript file for the event handling. As such, the HTML file has the dependencies on the CSS file and the JavaScript file. So there will be three bit streams. So there is one-to-one mapping between a bit stream and a file. So there are three files, so there will be three bit streams. And out of this, one should be marked as a primary bit stream, which shows up in a collection. And obviously, the HTML file is a primary bit stream, which has the dependencies on the CSS file and the JavaScript file. So this is a sample bit stream format, which consists of file format, encoding of bit stream, UTF-256 standard, my multipurpose internet mail extension, and name of the type. Few examples of MIME types are application PDF, or audio file, audio MPEG, video file, video MP4. So this figure depicts a typical workflow in DSpace. So whenever the document is submitted to a DSpace, directly it will not enter into an archival system. It will undergo what is known as editorial review, where it can be accepted, edited with few changes, or rejected. The editorial process is referred to as workflow. In this figure, there is an unfinished submission which enters into the workflow step 1, where it may be accepted or may be rejected. If it is rejected, it will enter into the unfinished submission bag, and if it is accepted, it will enter into the workflow step 2. At step 2, again, it may be accepted, rejected, or there may be some changes which has been suggested by the workflow supervisor. If it is accepted, it will enter into the step 3, and again the same procedure is repeated, and if it is accepted at step 3, finally it will become available in DSpace. So e-person or e-people. Every authenticated user in DSpace is referred to as e-person. Also, you can have different persons in the same row. This group of persons is referred to as e-people. The user can self-register depending upon the site configuration, who can later on be authorized to perform certain tasks in DSpace. So there are different roles which are inherent into the DSpace. Those are DSpace administrator, item submitter, item subscriber, user with permission to upload and read the restricted content, submission workflow supervisor, submission workflow participant. The administrator is having all privileges in DSpace. Removing items from the collection. So there are two ways of removing the items from the collection. If the user is having the sufficient privileges, he can withdraw an item from the DSpace, and the administrators can delete an item from the DSpace. Now we will see what is the difference between the withdrawing and deleting an item from the DSpace. Each item submitted to DSpace is characterized by unique identifier, is referred to as a handle. Withdrawing an item removes it from the view, so it does not show up in the collection. The withdrawn item is recoverable. On the contrary, if the item is deleted, it is referred to as expunged, and it becomes unrecoverable, and handle cannot be reused. So this can be compared with deleting an item from the windows which enters into recycle bin. You can drag it out of recycle bin for recovering an item, but once it is deleted from recycle bin, it will be permanently deleted. Similarly, all the expunged items will be deleted from the trash, which will be permanently deleted. A normal user can withdraw an item, whereas only admin can expunge an item. The personal workspace of DSpace. Each e-person is assigned some workspace which is for his personal use, referred to as a personal workspace. All the incomplete submissions are present in the personal workspace of a DSpace user, which are on their way but incomplete. The steps involved in the submission to archival are shown below. User starts the submission process. Fresh item is created in user's personal workspace. Content and metadata are added to the item. Once the submission process is complete, if there is any workflow associated with the collection, then the workflow will be initiated. If due to some reason in any of the steps of the workflow, if the submission is rejected or some suggestions have been given for editing the item, then it will be moved back to the user's personal workspace. The user can retrieve it from his own personal workspace, edit it, and then he can work on the item without having to start from the spine. So where he left off, he can start the submission procedure. Browsing or discovery. Browsing the DSpace content is referred to as discovery, which limits the user view to a particular index. The browse subsystem consists of the indices for item title, item issue date, item author. The DSpace data is indexed on these three fields for the fast retrieval of the data: the title, issue date, and the author. Authentication in DSpace. There are three types of users in DSpace. Unauthenticated, which are also referred to as the anonymous users, who can retrieve the item from the DSpace or search an item, which is referred to as document discovery. Authenticated user with restrictions, a normal user who can submit an item to a DSpace or receive the email alerts if they are subscribed to any of the collections in DSpace. Authenticated user having access to all the functions of DSpace and administrator. DSpace supports several authentication mechanisms. Username password-based authentication, where the password is stored in the hash format in MD5 salt format, which is very hard to break. X509 certificate-based authentication, where the certificate must be installed in the browser and must be installed properly on the DSpace server. IP-based authentication and LDAP, so lightweight directory access protocol based authentication. And we'll be relying mainly on the first step, that is the username password based authentication. So DSpace authorization policies. During the logical structure of DSpace, we have seen the hierarchy of the components of the DSpace. At the top level, we have the community. Community consists of collection. The collection consists of item and the bit stream. You can define different policies, the authorization policies at each of these logical components. Policies can be defined to restrict access to the digital content based on the identity of the user and the group of which the user is a member. Policies are inherited. For example, whatever the policies are defined in community will be inherited by the collection. All the policies of the collections will be inherited further by the item and then by the bit stream. So the table depicts the different permissions available for different logical components of DSpace. So bit stream authorization. So there are two permissions available for bit streams, read and write. With the read permission, the user will be able to open the file, and with the write permission, the user will be able to alter the contents of the file. Item authorizations. Now, in addition to read and write, there is an additional permission for the item, add and remove. If there is an add permission, so the bit stream can be added to the collection, and if there is a remove, so it can be removed from the collection. But again, it can be recovered because it is not a permanent deletion. It can be recovered by using the handle, which is a unique identifier for that particular item. The different permissions for the collections are add, remove. Items can be added or removed from the collection. Default item read. So if this permission is set, then every item which is added to the collection will automatically get the read attribute. Similarly, default bit stream read. So this permission enables read authorization for all the bit streams which are associated with the item added to the collection. The collection admin, items can be withdrawn or edited. So community authorization. So there are two permissions, add and remove, where the collections can be added or removed from the community. So the DSpace user UI. So as I told, in the DSpace architecture, the presentation tier hosts the different types of user interfaces to an end user. Out of this, the two are very, very popular. One is JSP, which stands for Java Server Pages UI, and the second one is the XML, Extensible Markup Language UI. Normally, the XML is used by the admins and JSP is used by an end user. And DSpace 7 onwards, the few more user interfaces have been added to DSpace: Ruby on Rails, Ember.js, Angular.js, Spring MVC, Spring Boot. Ember.js and Angular.js are meant for the mobile devices. JSP UI provides the web user interface. The web UI enables e-people to perform the following tasks: view e-content, discover, that is search e-content and browse indices. The indices are on title, author, and the date of submission of the item to the DSpace. Submit item to the collection, update and delete an item from the collection, submit metadata to the collection, perform workflow tasks. Once the user is authenticated, he can perform any of these tasks in DSpace. The section of UI enabling this is known as My DSpace. So these are the few major DSpace websites in the world, the educational institutes which have been successfully hosted their digital content on DSpace. So this is the view of DSpace as MIT, the one who created DSpace along with HP Labs. And MIT DSpace currently hosts 64,671 documents. DSpace at Cambridge, 1,93,188 documents have been hosted as of now. At Harvard, 12,202 documents have been hosted by the Harvard. So Texas, Knowledge Bank of Ohio. And now we'll look at InflibNet, the Shodhganga, where the theses have been uploaded, and currently 7,736 theses are available. For managing these theses, it is using DSpace. National Institute of Science. This is the DSpace homepage hosted by National Institute of Science. Now hold your breath. DSpace at CCyber. So the structure is ready. The content is yet to be uploaded. So we'll need to sit and think about the design policies, the type of the content, the structure, everything, and we will upload the content into DSpace. So that's all from my side. Thank you very much for sparing your time. Have a good day. Take care.